Okay, welcome back. Please mute your mic. Okay, welcome back to calculus and linear algebra. We will start today with the last topic, which is please mute your mic. Okay. Please mute your mic. Okay. Thank you. So welcome back to calculus and linear. Please. Hello.
ترى مرة ما شيء يوديها حد.
I have 240 students. I don't know who is talking. Please, if you know your colleague, just write me. Who's talking?
والله خليه عبر عن الدكتور.
I think Muhammad.
Which Muhammad is speaking?
Muhammad Mustafa, Doctor.
Muhammad Mustafa. Are you listening? Anyway, let's back to the third topic. You remember we mentioned that we have 3 topics to be discussed this semester. The first topic was vector calculus. We completed this topic. The second one is matrices, determinant and solving set of equations, linear and differential equations. We already completed. And the last one is differential equations. Differential equations to be discussed in 2 parts. Part number 1 is the first order differential equation, and part number 2 is the second order differential equation. This is week number 8, the first week of module 3. Today I will revise with you the integration. Already you study integration and differentiation in previous semester, but just we need it for solving differential equations. For that I will revise it with you, and then I will start with terminology. After that, next session we will solve differential equation using the first 2 methods, because we have different methods. We will see that we have direct, separable, non-separable, exact, non-exact, linear, Bernoulli. We will use these methods to solve differential equations. So let me back to differentiation and integration. And before I start, okay, I would like, what happened? Okay, I would like to tell you the story behind integration and what we are doing here. Now let me take it part by part. You remember in level 1, you already study functions. And the story behind functions is back to 200 to 300 years back. Many scientists, some of them Galileo, Newton, and other, let me say, scientists, they've been watching the natural phenomena occur in the nature. As example, day and night, light, darkness, waves, light wave, sound wave, water wave, and so on. And then they described them. Then they came to represent them by using tables X and Y, and then they represent them graphically. They plot the table, and then they derive a formula which is called equation, which have right hand side, left hand side, and equal in between. We call it function. After that, the science, the mathematics, start to be improved to classify these functions. Then it has been classified into linear, nonlinear, quadratic, cubic, and so on, exponential, power function, logarithmic function, trigonometric function, and so on, algebraic function. Then the science improved more to check these functions, because at the end these functions represent some physical stuff available in our world, in our nature. As example, let me give this example. If we have light bulb, okay, light bulb, and we have here a battery, okay, then this is the battery, this is the wire, this is the lamp, and we got light here. Okay, light. Now I can represent this circuit by a formula which say V equal I R, as you study in electrical engineering, right? In electrical, you represent the voltage coming from the battery times the current flow through the conductor or the wire times the resistance of the lamp. Okay, this formula is let me say mathematical representation of a nature, something nature available in our world, physical, let me say, system. The same thing could be applied for any physical system available in our world. Okay, we represent it by equation. Now, later, these equations, these functions have been tested to see their limits. It's important to know, to predict their limits. I mean, I know how it perform. As example, I know my car, how it perform if I drive it from here to Muscat. But if I drive it from here to China, what will happen? If I take it outside the world to the universe, what will happen? And you can measure on this example any other example. The limits came, and limits open the door for important part of calculus, of mathematics, which is called calculus. Calculus is a branch of mathematics.
ولا تحصل واحد ما نعرف شيء الترتيب. المهم نمشي ندور مني ومنك إذا حصلت شيء مرة هني يسدحوا في الجروب. دام أغلبهم عندهم بالمادة هني يسدحوا.
Hello.
Yes. I don't know who's speaking.
لا إن شاء الله بنحصل إجابة. زين أقول.
يعبر عن.
Okay. Now, what happened is you are listening. Just write me message. Say yes, if it is okay. My sound is reaching you, right? Just one of you at least. Great. Thank you, Zahra. Thank you. That's it. Okay, I'm following. Okay, it's fine. So what happened is the calculus, which is a branch of mathematics. I'm still with my story. With mathematics, branch of mathematics, which deal with different, let me say, operation. One of them is differentiation, and the second one is integration. One opposite to each other. Differentiation, when we deal with continuously varying functions, as example, rate of change of speed with respect to time would give an acceleration, or distance with respect to time give me speed. And integration is the opposite of this. When we go forward in differentiation, we return backward, okay, in integration. Integration, you study this in level 1, as you remember. Let me just, okay. You have the standard functions, table for the standard functions. As example, integration of ax to power n with respect to x. We did it in this way. Integration, this is the simple for integration. And dx, it means with respect to the variable x. And here, ax to the power n is the function. You study it in this way. You say, okay, a is a constant, I keep it. And x rises to power n, I will improve it and by adding 1. So a to power n plus 1 divided by n plus 1. Also, what we did, we put here constant, we call it integration arbitrary constant, just in case if my function contains constant and has been differentiated and it goes to 0, I take it in this way. We can find it if we have limits, or let me say boundary or initial condition for my integration. Now these are general functions. The normal function, the cosine function, the sine, the secant, cosecant, cosecant cot, secant tan, exponential, 1 over x, all of them represent a standard function. What does it mean? If I have similar to this function, directly the answer is taken here. You see here, this is the function. Example, this is constant a, 8. Integration of 8 with respect to x, I understand 8 is 8 multiplied by x to 0, because x to 0 is 1, so x is not there. Now, if I integrate according to the formula, it say a x to power n plus 1 over n plus 1, I will say 8x plus 0 plus 1 over 0 plus 1. Oh, wow. 0, what happened? 0 plus 1, which means 8x. I added c as a constant. What if I have more than one item in the function? 3x, 2x, square minus 5. I will take them one by one. 3x, it will be 3x square over 2. 2x squared, it will be 2x to the power 3 over 3. Minus 5, it will be minus 5x, as you can see here. And one constant is the arbitrary. You can work with different examples. I gave you here different examples. You need to use the principles we use in simplifying equations, then you convert it to standard function, then you solve it. As example, this fraction here, I will split it into two fractions. This is 1, this is 2. I simplify, cancel here with here, there's 2. I'm reach this point, then I go for integration. The same thing for cosine, the same thing for many items here, 1 over x here. These are extra example. You solve many example last semester related to the standard function. Now the question here is, what if my function is not standard function? What should I do? I go for the techniques. You study the techniques. 4 main techniques have been studied here. Algebraic substitution, trigonometric substitution, partial fraction, integration by part. I'm still revising what you already studied in level 1, semester 1. Now, if you look here, this function, okay, I know integration x to power 7 dx, how to solve. Directly, I will say x to power 8 over 8 plus c, done. But what if 2x, as you can see here, minus 5 together in a bracket rises to power 7? What this mean? This means that this bracket is multiplied 7 times. It means 2x minus 7 by 2x minus 7 by until 7 items. If you open them, you have long expression. Difficult to solve in this way and time consumed. Now it's rises to power 7. What if it is rises to power 100? You cannot solve it easily. Now there is method which is called algebraic substitution. I will try to give example on each one of them. Now I will assume that what is inside the bracket here to be u. And I will differentiate u with respect to x. Differentiation of 2x minus 5 give me 2. Because 5, 0, differentiation of 5, 0. And 2x give me 2. Okay. Now I will convert the original integration from function of x into function of u. So dx to be changed in this way into du over 2. And this part which is u, it will be u to power 7. You see here, u to power 7 du over 2. Take 2 outside here, it will be 1 over 2. Have a look here at this integration. It's a standard integration. So directly I will say u to the power 8 over 8 plus c. As you can see here, u to the power 8 over 8 plus c. Now the final step is to substitute for u and return back to x. U is this one. I will substitute u. It will be 2x minus 5 to the power 8. Very simple. Okay. When you have time after I finish my session, try to check this and its solution. You will find that it is the same trend. The second method is by using what we call it integration using trigonometrics. You are given table here. This table contain 12 rules, all of them related to trigonometrics. Now this let me say table tell you that if your function is cosine square x, I know how to integrate cosine x. But cosine square x or cosine to the power 7x is something different. Okay. So if it is cosine square x, I use this result. This is the result of this integration. How he reached this in the table? By using this method. So if your function is cosine, this is the result of the integration. Sine square, cot square, cosine by sine, okay? Sine by cosine or cosine by sine or cosine cosine, sine sine, or similar to one of these functions. Always you have results for the integration. Let's apply one of them. Okay, have a look. he told me here integration sine square. Integration of sine easy to find, but sine square something else. So what I will do, I will say, okay, go ahead, sine square x. He used this method to solve to find this result. You see here, I will come sine square 3x. It means 1 over 2, 1 minus cosine 6x, because 2x by 3, 6x. Now when I substitute for this part by this part, easy to integrate, because integration of 1 is x. Integration of cosine is sine, right? 1 over 6 sine. So directly I got the result. The table helped me to find the integration. Method number 3, which is called integration by partial fractions. You remember partial fraction, you study this in the foundation in GFP. When you are given fraction which is complicated, what you do? You simplify it and split it into simple separate fractions. This is what you do. Now, what happens is you will solve it based on the type of the denominator. You remember in foundation, you study this, and even in secondary school, you classify your fractions into linear, repeated linear, quadratic, and based on the type of denominator, you will find the fraction. Now you are given here integration of this fraction. I can see I cannot solve it using standard functions. I cannot solve it by substitution, algebraic substitution. I cannot solve it by trigonometrics. But since it's fraction, I can solve it by integration using partial fractions. So I will convert this integration, this fraction, sorry, into simple separate fractions. You convert it. This is a fraction number 1, fraction number 2. I will not revise with you partial fractions. You study this in secondary school and in foundation. But you got these fractions. When I got them, it's now easy to integrate, because take 2 outside. 1 over x minus 1 give me ln. 1 over x plus 3 give me ln. So in this way, I can solve the fractions. Last method you study last semester, I'm still with my revision, is integration by parts. Integrating by parts. Integrating by parts applied, this method applied when we have functions different in their nature. As example, cosine is a trigonometric, exponential x is exponential function. They are different. Cosine x and x, they are different. X and exponential x, they are different. In this way, we can use trigonometric by part. What the rules say? The rules say if you have integration of two functions, u and the derivative of the second function dv, then the result is uv minus integration of v du. Very simple. I will take one example here and then to finalize this revision. Then I will start with my topic. If I look to this function, x here is normal function, x function, linear function, okay? Now, cosine here is a trigonometric function. Now, let's assume x to be u, this one to be u, and cosine x dx to be dv. Now, since I have u, let me find du over dx, which give me 1. And since I have dv, let me integrate to find v. I integrated, I found v sine. Now, next step, I will substitute in the formula here, u, v. Where is u, x? Where is v sine x? Minus, because the rules say minus, you see here? Integration, v. Where is v sine? Where is du? Du is dx. I will write here dx. Integration of sine is minus cosine, as you can see here. So just minus by minus a plus, I got the result. So this method is used, we use this method when we have two different functions in their nature. Okay, after this revision, let me start with differential equation. Now we differentiate y. Usually I use y as a subject. We differentiate y. As example, you can see here, this is y, dy over dx, differentiated is found to be this value. This is called differential equation. Why? Because the subject y here has been differentiated. Okay. Now, very simple definition. When I say I want to solve differential equation, it means integrating to get back to y. Y has been differentiated. Tell me what should y be. Okay, tell me how I find y. So I use the integration, the method you already studied in level 1, semester 1, I just revise it. Now, so let me read here the definition for you. An equation, differential equations, an equation contains the derivatives of one or more dependent variables with respect to one or more independent variable. Y is a function of x. Y has been differentiated. We need to integrate to get y. Very simple. Now, sometimes y is function of only one independent variable. Only, as example here, y is function of x. Sometimes the variable is more than one variable with one independent. As example, x and y, both of them function of t. So we differentiate them. Now, when the variable, let me say I have one variable which is y, but the variable is function of more than one independent variable. As example, y is a function of x and z. So when I differentiate with respect to one of these variables, we call it partial derivative of partial differential equations. You will study this inshallah next semester in semester 1, level 2. As example, here u is a function which is depend on x and y, function of two variables, x and y. Now, when I differentiate, by the way, here 2 mean it's differentiated twice. Mean I differentiate and the result I differentiate it again, as you study in level 1, semester 1. Now here we differentiate with respect to y, it means keeping with respect to x, keeping y constant. And if I differentiate with respect to y, I keep x as a constant. This another topic to be discussed next level, level 2. Now, for differentiation, how we present differentiation? We presented the normal way, which say, as example, dy, I don't know what's happened, dy over dx. This is called Lipin's notation, okay? Or another way, I write d square y over dx square. It means I differentiate y twice with respect to x. It's called Lipin's notation. And the second presentation, I'm talking about these methods because you will find different textbooks. These textbooks either use this notation or the other notation. You need to know them. But at the end, we will use mix. Sometimes we use the prime notation, sometimes Lipin's notation. Prime notation is written this way, y prime, y double prime, or they call it y dash, y double dash, y triple dash, and so on. The third method is subscript notation. It means, as example here, when I say ux, x you see here subscript, it means that u function u has been differentiated with respect to x. While here, as example, it means u has been differentiated with respect to x and the result has been differentiated with respect to y. Okay. Now, still with the terminology, this session, I will just define the terminology, and then next session, inshallah, we will start with solving the differential equations. Order, after I talked about the notation, the partial differential equations, let me talk about the order. We hear first order, second order. What does it mean? It is the highest order of the derivative. It means, have a look at this one. d square y over dx square, it tells me that y has been differentiated twice. This two twice. It means the order of this differentiation is second order. While this one, dx over dy, has been differentiated one time. Yes, you may say this is power for the whole bracket. This doesn't mean this is order. This is power. but it is not the order. Order is how many times we differentiate. So this is the meaning of highest order, highest derivative order. Now, the general presentation for ordinary differential equation is defined in this way. We have the independent and the variable, which is y, could be more than one time has been differentiated, equal to 0. This is the general form. We solve it, we put it in this way, the highest order, and then we solve it to find y. Now let me come to the another property in the terminology is the linearity. Now the differential equation, the ordinary differential equation, okay, could be linear equation or non-linear equation. What we mean by linear equation or non-linear equation? Non-linear, linear we know, understand, it's a straight line equation, the normal, y equal mx plus c. But if some sort of non-linearity occurred to the equation, as example, it become quadratic, x square. X square is non-linear because you know this is the linear. This is how it like the linear line. X square it means parabolic, which is non-linear. You see here, it's curve. So, as example, this equation, dy over dt, nothing here to tell me that this is non-linear. It's normal. Y differentiated with the variable t, plus y, which is the variable, equals 0. This is linear. Now, here the variable is x, not y. Differentiates with respect to t, it's okay, it's fine, nothing wrong here. But the variable x rises to power 2, no, this is non-linearity. So I say this is non-linear. If I come to this, differentiation of y with respect to t, my unknown is y. Differentiate with respect to t is okay, it's fine, nothing wrong here. T square, just a minute, t is the independent, it's not the dependent. So it doesn't matter if it is go to power 2 or 3, 4, it doesn't matter. Here, the subject, my subject is x. I want to solve to find x. Here, I want to solve to find y. So anything to be raised to power 2, excluding the subject, it doesn't matter. Now here, also it's non-linear. Why? Because y and its derivative came together, multiplied by each other. This give me that, tell me that this is non-linear. Now, also, if you see this one, this is when I multiply y dash here and here, y dash by 1 is okay, but y dash by y, non-linear. Y, I take sine for y, non-linear. Sine is give me non-linear, but parabolic, trigonometric. Y square, non-linear, because I have square here. So all these sort of non-linearity. After I define the non-linearity, linear and non-linear, the order, let me go to the degree. Degree, okay, of the differential equations is the power of the highest order derivative. What this mean? Have a look. Now here, this equation d square dy directly. So this is second order. I understand that this is second order because the highest order here is 2. But since here the power here for this highest order is 1, the degree is 1. Let me come to the second example. D to the power 3 and here dy directly. So it tells me that this equation is third order differential equation. Why? Because y here has been differentiated 3 times. The power here for this differentiation is 4, but the power for the highest order is 1. So I say the degree is 1. Let me take another example. Now here, this is the second order and this is the first order. I don't care about the first order, just look at the second order. What is the power? 3, I say the degree is 3. Now, how we solve it? How we solve it? We solve the differential equation to find y. I am given dy over dx. Solve it, it means getting y. So definitely we'll say, okay, let's integrate that. This is what we are going to do. For that, I let me say revise with you the differentiation. Okay. Now, if we come here, verify the indicated function is a solution of the given or ordinary differential equation in this range. He told me prove that this differential equation, the solution of this equation, this differential equation is y equals x to power 4 over 16. I will solve A, B, you will read the solution later on, but let me solve A. I will come, okay. Left hand side is this dy over dx, okay. If I differentiate dy over dx equal 4, okay. Where is it? Okay, x to power 3 over 16. This is y, okay. When I differentiate this one, right hand side, sorry. When I differentiate y here, it will be dy over dx equal 4, because you remember ax to power n, right? 4x to power 4 minus 1 over 4 minus 1. Sorry, 4x to power 4 minus 1. This is differentiation. What it give me? X to power 3 times 4. This is 16 in the denominator. Now this is what I got. Okay. Now if I go to this part, okay, this part, and let me substitute for y by this value, x to the power 4 over 16. I substituted. I take square root. For this one, it becomes square x to the power 2. For 16, it becomes 4. Let me simplify, multiply these, it gives me x to the power 3 over 4. Now, left-hand side equal right-hand side, then this is the solution. Yeah, when I say this is my differential equation, I solve it. This is my solution. If I differentiate y, I should return back to the original function. Got it? Now the second one is not far away from this. You are given here second order differential equation, and he told you that this is the solution. Then I will substitute y here. I will differentiate to find y dash and substitute it here. I differentiate again to substitute here. I got this expression. If I simplify it, it will be 0. 0 equals 0, then left hand side equal right hand side, that my solution is correct. Now I will stop here. And if you have a question,